Okay, let's first talk about what is the fate of the universe if it continues to expand. So here are some things that's going to happen in the future. First, the Earth is going to run out of conventional hydrocarbons in about 50 years. They've been saying that for the past 50 years. But anyway, we think that in the future we're eventually going to run out of oil and natural gas. So they think currently about 50 years into the future. Okay, the next thing that's going to happen is in about 138 years, the United Federation of Planets is going to be founded. Star Trek. I couldn't resist. All right, so anyway, that's what's going to happen in the future. It's true. All right. So then the next thing I put down was the time needed for radioactive waste to decay. Well, it depends on the kind of radioactive waste. So some types of radioactivity have very, very long half-lives. So that means it's going to take them a very long time to decay down to where they're safe materials. But we think that between 1,000 and 10,000 years is more than enough time for nuclear waste to settle down. Okay, then the next ice age we think is going to occur in approximately 50,000 years from now. Okay, then the next magnetic field reversal. So when we talked about the Earth, we said it had a magnetic field, and that every 200,000 years or so, the magnetic field of the Earth flips, and north becomes south and south becomes north on your compass needle. And so we think that the next time that the magnetic field is going to reverse itself is going to be in about 100,000 years. Okay, the next thing is that the city of Los Angeles, California, and the city of San Francisco, California, will be next door neighbors in about 15 million years. And that's because Los Angeles is on one side of the San Andreas Fault, and San Francisco is on the other side. And because of the movement of that fault, it's actually carrying San Francisco towards Los Angeles, so that in about 15 million years, the two cities will be on opposite sides of the fault zone. Okay, then in about 200 to 300 million years into the future, we think that the continents will come back together, and then we'll have another supercontinent. In about 500 million years into the future, our sun is going to become increasingly unstable. So do you remember Cepheid variables, where these stars that would periodically get larger and brighter and get hotter, and then gravity would take over and it would pull them back in, and they would get cooler? So eventually our sun is going to start to become unstable in the amount of energy that it produces. And at this time, that's when we need to move. So here on Earth, the weather would get increasingly worse, the oceans would begin to evaporate, and all of this is going to start to occur in about 500 million years. And then in about 4.5 billion years into the future, the Andromeda galaxy is going to collide with the Milky Way galaxy, our galaxy. So those are just some things that are going to be happening in the future. Now, for purposes of the exam, don't worry about it. None of that's going to be on the exam. I just put that in there so that you would be entertained. Were you entertained? I hope so. Now, here is, though, something that will be on the exam. So what's going to happen in the future? The sun is going to die and is going to become a red giant in about 5 billion years. So you should know that for the upcoming exam. In 5 billion years into the future, our sun is going to start to run out of hydrogen, and then the core is going to collapse, the outer part's going to puff up into a red giant. Okay, the next thing that's going to happen is that eventually clusters of galaxies will have merged. So remember that our galaxy is currently gobbling up a dwarf galaxy. And we just got through saying that in about 4.5 billion years into the future, our galaxy is going to be gobbled up by the Andromeda galaxy. So that by the time you get to 4 times 10 to the 10th years into the future, so that's 40 billion years into the future, now galaxy clusters will have coalesced into giant galaxies. And then all light elements will be used up, and the universe will eventually consist of planets, black dwarfs, neutron stars, and black holes. So eventually all the hydrogen in all the usable hydrogen in the known universe is going to be used up by stars. And so stars are going to begin to die, and so we know that the end point of stars is either being a black dwarf, a neutron star, or a black hole. And this is going to be 10 to the 14th years into the future. Okay, now that is as far as what you need to go for purposes of the exam. But we want to go further, okay? So let's go into the future even further. Galaxies will undergo mass segregation. And so what this means is that more massive objects, like black holes, are going to fall into the centers of galaxies, but in order to conserve angular momentum, that will eject other particles and planets and stars out of the galaxies. And so massive objects like black dwarfs and neutron stars are going to be flung outwards, and this is 10 to the 20th years into the future. Okay, so a billion years is 10 to the 9th, so that would have been a billion, 100 years into the future. Okay, protons decay into neutrons and anti-electrons, and the planets disintegrate. So currently, the reason why you exist is because your atoms are glued together because of the electromagnetic force. So inside the nucleuses of every atom inside your body are protons, and then there are electrons, negative, that are in orbit around them. And because positive is attracted to negative, that holds them together. But we think that protons can eventually turn into neutrons through the weak nuclear force. And if that was to happen, then in the nucleuses you'd have a whole bunch of neutrons. And now there would no longer be any electrical force holding those electrons in orbit, so matter would disintegrate. Atoms would disintegrate, you would disintegrate, planets would disintegrate. And so that's going to be 10 to the 34th years into the future. And then 10 to the 43rd years into the future, stellar objects are going to collide into larger and larger black holes. So now the universe is going to consist of only black holes. It's going to take a long time for this to happen. Okay, let's go further into the future. So now this is the black hole era. And do you remember Stephen Hawking, the guy in the wheelchair? All right, so Stephen Hawking did a lot of work with black holes. And he also knew that it was possible for matter and antimatter to appear out of energy. And so he hypothesized that a black hole has a lot of energy. And so it can use that energy to make matter, subatomic particles, and antimatter, subatomic particles. Now let's assume that now we're talking about things like electrons and anti-electrons. So let's imagine that some of the energy of the black hole, which is coming from its mass, Okay, remember that E equals mc squared. So that means that mass can be converted into energy, and energy can be converted into mass. So let's assume that some of the mass of the black hole is converted into energy, and then that energy is turned into an electron and an anti-electron, matter and antimatter. Now let's assume that this happens inside the event horizon of the black hole. Well, that doesn't help, because both particles would be sucked into the black hole, so they didn't escape. But imagine that the electron and anti-electron appear outside the event horizon. It's possible that they could escape the gravity of the black hole. And so it is possible that a black hole will begin to shrink. It will get smaller and smaller, because every time this happens, it loses the mass of an electron and an anti-electron. Now remember, these things are teeny tiny. So we're starting off with an object that is, billions of kilograms in mass, okay? And now it is less in mass by the mass of a single electron and anti-electron. So it's going to take a long, long time for these black holes to evaporate. So now we're talking about 10 to the 100 years into the future. And so if you're interested in it, here's a little video that you can watch that talks about how black holes can evaporate. But we're not finished. So let's go into the future. So now we are into the dark era. And so now the universe consists of electrons and positrons and other subatomic particles and light. Now eventually the electrons and the positrons will go into orbit around each other, kind of like a binary star system. So they have opposite charge, so they would be attracted to each other, and it's possible that they would go in orbit around each other, and they would make a kind of atom, meaning that, yes, there would be now, I don't even know what you would call it, so this would be the electron anti-electron hotel. And so this is where the electrons would live, and they could jump up and down energy levels, and they could emit different kinds of light when they would do that. They would eventually, however, spiral in together and annihilate, forming more radiation. So now the universe only consists of radiation. And the universe is expanding. So do you remember when we talked about the cosmic microwave background radiation, which started off as being visible light, but because of the expansion of the universe, it was turned into radio waves? So the light being emitted when these particles annihilate probably is going to start out as being gamma rays, very high energies. But as the universe continues to expand, then it's going to go from gamma to X-ray to ultraviolet to visible light, and eventually it's going to turn into radio waves. And the size of these radio waves will just continue to get larger and larger and larger until they become infinite in size. And so that is the end of the universe if it expands forever. Kind of depressing. All right, so let's take a break, and when we come back, let's talk about what would happen if the universe collapses.